So today is for chapter 5 and it's for measurement with graduated scales and scaled instruments. So you have to know what is rule and what is scale. A scale is graduated in proportion to a unit of length, and a rule is the unit of length, its divisions, and its multiples. So the difference is right here. For scale, we're talking about the proportion. This is the scale, and it represents, so these are your graduations, and they represent feet and inches. So you can see the proportion right there. Another scale, and this time it's decimal division of feet. You can see the proportion right there. And this is your rule, and here you can see the graduations, and they represent inches. So here we go. You're gonna take a look at the discrimination. That's just a term. Just telling you the number of subdivisions on a unit of length. And you can see here the finest division right there is 2 miles per hour. Therefore, the discrimination is 2 miles per hour. So here the discrimination 116, 18, 164, 132nd, and they're all fractional inches. And this one is your decimal inches, metric in millimeters. We can see right here 0.01, that's your decimal, again inch, metric in millimeters. And these are all that we use for scales in the United States. So the right way to use a rule is usually the easiest. And here you can see they're wrong because the way that they're using this reference point is wrong. So the reference point got to be totally aligned with the inch line. And here, and here. On this side, the sharp edges are better and they're the best. If you have like curved or rounded edges like that, alignment is very difficult. This is just showing you in order to compensate the metal shrinkage, because metal usually shrinks as it cools and solidifies. So to compensate that, we have a special rule and we call it the shrink rule. So reference point is where you want to start to measure, and then your measure point is you're going to measure up to that point. So that's the start point, that's the end point, and you're going to coincide the graduation here on your rule or the scale. So when the reference point and the measure points are carefully aligned, you will get the correct measurement. And you have to use a proper discrimination to get the right precision. So you can't use 1/16 scale if you want to get a 0.02 scale, okay? You have to use that 0.02 scale. You can't use a 1/32nd scale for 164, measurement. So measurement errors can happen, they always happen, and that's because your instrument error inherent and or your observation error, your eye sight, and your manipulative error or your hand, and the last one is biasness. Here this is an example of your observation error. We call that eye error. So when you have a dimension perfect part 164 3 times, and sometimes your eye is going to read it over or under that. Okay, so here is you have like a 0.0015 potential observational error on either side of that dimension. Another observation error is called parallax error. So that's just a visual error, and it usually happens when the observer changes his or her position. Here are the common manipulative errors. So here this is wrong, do not bend or cramp, okay? And here this is also wrong because the rule is not along the line of measurement. These are all right, and this one is wrong because you have an obstruction here. In this way of measurement, both of them are correct. And here we're using the support. And here the line force holds the rule against the suitable surface for alignment with line of measurement. Bias is another error when the observer unconsciously influences the measurement made, because observer might want to read 14 centimeter instead of accurate 13.5 or 14.5 centimeter. Here the same thing. This is the actual measure point. You might want to read it like lower than this or higher than that. So we have three groups of scaled instruments: rules with mechanical refinements, related devices that are used with rules, for example, calipers, your verniers, that's the refinements of the steel rule. This is a depth gauge and is a popular modification of the steel rule that measures into holes, grooves, and recesses, making inaccessible points of measurement accessible. So we use this depth gauge to check the progress when we are machining holes or recesses. So this is just showing you the rod type and the blade type for depth gauges. You can see how we measure the holes. So a combination square set. So you can see here we have a blade. This is your blade. It just rule all the scale, and then we use it with either center head or protractor head or square head. So the center head has a clamp, and the protractor head has a blade clamp, your turret. So you can see here the turret clamp, and here is your level, and you have your reference mark right there. And for square head, we have clamp, level, and the scriber. This is just showing you right here, the detail of the turret. Combination square is really good because it gives you higher reliability than rule or scale measurement. So here, eyeball it, it's very poor reliability. Here, if you use a reference block, that's also poor reliability because it's not stable. But if you use a combination square here, your reliability is pretty good. Here it's just showing you your square head, and the combination square can be used from a flat reference. Okay, so here you can see your reference point. Here, that's your measure point. So for depth measurement, square head offers great range and better reliability than the depth gauge. So A and C here is right, and B and D is wrong because here it's totally off, and here it's not. X and Y, when you look at it, is being larger, okay? Y is, and here is completely proportional, so there's your force right there. Here in A, this angle does not matter, but this one does, okay? Because it's giving you the force to stabilize the entire setup. Combination square is equipped with protractor. This is supposed to be protractor head for angle measurements no closer than 1 degree. So that means that you can't accurately measure angles lower than 1 degree. In center head, we usually use it to measure diameters, and it is better and more reliable. So here B is the best. So combination square sets, we usually use blades. So blades of 4 scales. So there are 8, 16, 30 seconds, 60-fold or 4R, 30 seconds again, 60-fold, 50, 100, and 16 or 30 seconds again, half millimeter and 60-fold and 1 millimeter. 1 millimeter, half millimeter on both sides. So when a blade has only 2 positions with respect to the head here, so the scale of the blade and or inverted here is not reliable. So here this is the scale of the blade, and or inverted is not reliable, but the scale erected. So here I'm going to show you one right there. Okay, scale that is erected and or corrected if inverted is totally reliable. Accessories are the attachment, and if you use the attachment, you always have added error for every measurement, so make sure you check the accessories when in use to ensure a reliable measurement. Here are the reliable measurement with combination sets. So with very little practice, if you do all of this and make sure you're careful about all these precautions, you're going to definitely get a reliable measurement. Calipers, that's what we're going to do today. In the lab, the original transfer instrument, calipers, if you think about it, you think about it as a transfer instrument. We use it only to transfer the measurement from part to standard, and calipers are widely used in the tool room. So we have dividers outside calipers, and we have inside calipers. See the shape, they're different. And a hermaphrodite caliper. Looks with all the legs right there. Calipers were made to solve the problems of transferring measurement by using a graduated scale, especially measurement of radii of circles. We call caliper just a duplicating a measurement, and it's also called an adjustable instrument. So all caliper instruments transfer measurements. So there are some types of caliper here: dividers, outside calipers, inside calipers, and hermaphrodite calipers with odd legs. So dividers for line measurement, they are used to draw circles. It is used to divide any geometric straight line or arc. With dividers, we make geometry pretty easy. Line reference is nothing but dividers are used with line reference. The dividers, again, the transfer measurement, and every measurement involves 2 measurements, okay, involved in a transfer. So the lines to which the divider must be set determine the reliability of the measurement obtained by the dividers. Since the transfer of measurement is 2, you have to be careful with the errors because each measurement, they contribute errors. So therefore, transfer of measurement several times can lead to accumulation of errors. And any true measurement is affected by the part, the instrument, and the observer. So it may be increased or decreased. So for reliability, we must assume the worst. So the value when subtracted from other measurement, it might go down. The value when added to other measurement, it might go up than the true measurement. So however, in serial measurements, that's several measurement operations, if dividers are properly used, measurement reliability can be maintained, even increased. One of the advantages of divider is that you don't have parallax error. Okay, the error that can happen when you change or when the operator or observer change his or her position. Inside and outside caliper, well, we use them for measurements that are not clean cut lines and edges. So both caliper use reference points like all other calipers. And calipers, they have more in common with slingshots than rifle with no built-in reference surface, meaning like they don't have built-in reference surface. So since there is no built-in reference surfaces to align with the part, you definitely need your skill of measurement to get accuracy. So line of measurement for outside caliper position along the line of minimum separation. So that's the distance between surfaces that bind the feature being measured. And for inside calipers, position along the line of maximum distance. Here with the line of measurement for outside caliper, you're going to seek the smallest caliper opening that will pass the part. Again, in order for us to find the measurement reference line, we gotta go with the feel, okay? So feel with calipers, despite the various surfaces, recess or shoulder on the part definitely increases the measurement reliability. Inside caliper, inside measurement, okay, they're easier to take than the outside one. So inside measurements are easier because you always have the edge. So to increase precision in measurement with calipers, ironically, the instrument must be felt by rubbing it lightly against the part and rock it across the center. Most reliable measurements are made when the feel of both the pickup of the reference points and the comparison with the known distance is the same. So the importance of gauging pressure is nothing but there is something called gauging force or pressure, not just from rubbing, in using outside and inside calipers. And usually calipers are distorted, so operator of measurement can feel that rubbing between the part and the calipers. Hermaphrodite is nothing but one of the layout instruments. So this caliper, when you look at it, is called alt leg caliper because it has one curved leg and one divider leg. So we use them for scribing lines parallel with an edge, not very reliable. They're not very reliable. So here you can see scribing the lines from inside edge, scribing the lines from outside edges. And they both are poor reliability. We also use them to find centers of shafts for which center head cannot be used. So definitely hermaphrodites are better. Surface gauge is another layout scribing instrument, and it transfers height measurement and is used often on a surface plate for reliable measurement. So with a surface gauge, there is stable contact between the part and the instrument. along the reference point line. Here is a reference point, measure point, and here is the line of measurement. The scriber can be adjusted to a height measurement to scribe it on the part. So the pocket slide caliper rule, we usually call it slide caliper. It is a handy, sharp instrument. They come in various sizes from 2 inches all the way to 80 inches. And they can be locked and unlocked. So even if we have locking feature on slide calipers, they're not snap gauges because they cannot be adjusted for excessive wear like snap gauges can.